Today we discuss Module 5 Information Storage Management. The contents of the given presentations are storage array-based replication, full volume mirroring, pointer-based full volume replication, pointer-based virtual replication. First topic is storage-based replications. In the case of storage array-based replication, the host resources such as CPU and memory are not required for replication process, so that the host is not burdened by the replication operations. So the replicate can be accessed by an alternate host for any business operations. So that in this replication, the required number of replica devices should be selected on the same array and the data is replicated between source replica pairs. The given figure shows that the storage array based replication where source and target are in the same array and it is accessed by different hosts. Storage array based local replication can be further categorized into full volume mirroring, pointer based full volume replication and pointer based virtual replication. Replica devices are also referred as target devices accessible by business continuity host. In the case of full volume mirroring, the target is attached to the source and established as a mirror of the source, so that the existing data on the source is copied to target. New updates to the source are also updated on the target. After all, the data is copied and both the source and target contain the identical data. The target can be considered as a mirror of the source. Suppose if the target is attached to the source, it is unavailable to any other host, so that the production host cannot access the target, they can access the data from the source. When the synchronization is completed, the target can be detached from the source and it is available for any other business operation. The business host can access data from both source and target and they can perform both read and write operation, which is utilized by both production and business continuity host respectively. After synchronization is completed, the target can be detached from the source and it is made available for business continuity operations. The figure shows that full volume mirroring when the target is detached from the source. So in this case, both the source and target can be accessed for read and write operations by the production host. After the split from the source, the target becomes a point-in-time copy of the source. The point-in-time of a replica is determined by the time when the source is detached from the target. For example, if the time of detachment is 4 p.m., the point-in-time of the target is 4 p.m. After the detachment, changes made to both source and replicate can be tracked at some predefined granularity. This enables incremental resynchronization or incremental restore. The granularity of the data change can be ranged from 512 byte blocks to 64 KB blocks. Changes are typically tracked by using bitmap. In the case of full volume mirroring, if any updates occur to a particular block, the whole block is marked as changed, regardless of the size of the actual update. So that resynchronization, only the changed blocks have to be copied. This will eliminate the need for a full synchronization operation. This method reduces the time required for these operations considerably. In full volume mirroring, the target is inaccessible for the duration of the synchronization process until detachment from the sources. For a large databases, this will take long time. An alternative to full volume mirroring is pointer based full volume replication. Like full volume mirroring, This technology can provide full copies of the source data on the target. Unlike full volume mirroring, the target is made immediately available at the activation of the replication session. Hence, we need not wait for data synchronization to and detachment of the target in order to access it. The time of activation remains the point-in-time copy of source. Pointer-based full volume replication can be activated by two ways. First one is called as copy on first access. Second one is full copy mode. In both cases, at the time of activation, a protection bitmap is created for all data on the source devices. Pointers are initialized to map the empty data blocks on the target to the corresponding original data blocks on the source. The granularity can range from 512 byte blocks to 64 KB blocks or higher. Data is then copied from the source to target based on the mode of activation. In the case of full copy mode, all data from the source is copied to a target in the background. The data is copied regardless for access. If access to a block that has not yet been copied is required, this block is preferentially copied to target. In the complete cycle of the full copy mode, all data from the source is copied to target. If the replication session is terminated now, the target will contain all the original data from the source at the point in time activation. So this makes the target a viable copy for recovery, restore or other business operations. In this session, we discuss copy on first access mode. After the replication session is initiated, the data is copied from the source to the target when the following conditions occur. First one, a write operation is issued to a specific address on the source for the first time. Second one, a read or write operation is issued to a specific address on the target for the first time. When a write operation is issued to the source for the first time after the session activation, the original data at the address is copied to target. After this operation, the new data is updated on the source. This ensures that the original data at the point in time of activation is preserved on the target. In this section, we deal with the copy on fast access method from read from target. When the read operation is issued to a target for the first time after the session activation, the original data is copied from the source to the target and it is made available to the host. In all cases, the protection bit for the block is reset to indicate that the original data has been copied over the target. The pointer to the source data can now be discarded. Subsequent writes to the same data block on the source and reads or writes to the same data blocks on the target do not trigger a copy operation. If the replication session is terminated, then the target device only has the data that was accessed until the termination, not the entire contents of the source at the point in time. In this case, the data on the target cannot be used for a restore and is not a fully replica of the source. In the case of pointer-based virtual replication, at the time of session activation, the target contains pointers to the location of data on the source. The target does not contain data at any time. Hence, the target is known as virtual replica. Similar to pointer-based full volume replication, a protection bitmap is created for all the data on the source device and the target is immediately accessible. Granularity can range from 512 byte blocks to 64 KB blocks or greater. When a write is issued to the source for the first time after the session activation, the original data at the address is copied to a predefined area in the array. This area is generally termed as save location. The pointer in the target is updated to point to this data address in the save location. After this, the new write is updated on the source. When a write is issued to a target for the first time after the session activation, original data is copied from the source to a save location, and similarly, the pointer is updated to data in save location. Another copy of the original data is created in the save location before the new write is updated on the save location. When a reads are issued to a target, unchanged data blocks since session activation are read from the source. The original data blocks that have changed are read from the save location. Pointer-based virtual replication uses COFW technology. Subsequent writes to the same data block on the source or the target do not trigger a copy operation. The given figure shows that the comparison of local replication technology. In the case of full volume mirroring, it is the target is accessible only after the synchronization operation. But in the case of pointer-based and pointer-based virtual replication, the target is immediately accessible. In this session, we discuss storage array-based local replication and the various categories of storage array-based replication. That is full volume mirroring, pointer-based full volume replication, and pointer-based virtual replication.